Hello, let's continue our Sudoku adventure with Liczenie Owiec by GDC. It means counting sheep in Polish. All right, so we have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these dot count arrows. A digit on an arrow counts the number of visible or invisible white dots in the indicated direction. So let's go over what a white dot is. It just means the two digits are consecutive. So this white dot splits up these two cells. They have to be consecutive. So if this was say 2, 3, then that's consecutive. So that would be fine. We can't do 2, 4. That's not consecutive. We can also do 3, 2. We could do 3, 2 or 2, 3. The order doesn't matter. All dots are given, but some of them are invisible. So that really means they're not all given, but any two, like if this was say 2, 3, then there's an invisible white dot between them. We have these dot count arrows. A digit on an arrow counts the number of visible or invisible white dots in the indicated direction. So let's say let's do this one. Let's say this one was a 2. That means I have exactly 2 dots in this direction, invisible ones. So I could do say 3, 4, and then 6, 5, right? There could be a white dot between the 5, 6 and the 3, 4, but not between the 6, 4. So that resolves our 2 there. Okay. And then the white dot, we know, separates consecutive digits. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. I want to think about this. Okay. This has to be, it can't be 0. I think this can count the dot that's right here, right? So this can be up to 2. This can be a 1 or a 2. If it's a 2, then we have a completely consecutive sequence. Like it would have to be 2, 3, 4. If it's a 1, then these two are consecutive, but they could be anything. Or it could be 1, 2, and then this isn't consecutive. All right. So this is also 1, 2. That makes a 1, 2 pair here. So this has to be at least 3. It sees 4 no, it sees 1, 2, 3. It sees 3 intersections. So this has to be a 3. Meaning this, and this have to be consecutive. We can't go down because we go 2, 1, and then run out of digits. So we have to go up. We have to go 4, 5, 6. All right. And so then over here we have 4, 5, 6. This is 1, 2, and this is 1, 2, 3. These have to be consecutive. So it has to be the 3, 4. All right. These are not consecutive. So if we count, we could have 1, 2, 3. So this goes up to 3, which means we can't actually count this because we'd have to put a 4 here for this to be a white dot. So actually, it's not. It's actually maxing at 2, giving us a 1, 2 pair. This can't be 1, 2, 3, or 4. So it's only 5, 6. What else we got? This is a 5, 6 pair as well. So one of these is a 2, 3, 4 chain. Because once this is a 2 or this is a 2, we're going to go 2, 3, 4. Is there some reason one or the other doesn't want to do that? I'm not sure. If this was a 1... We can't do 5, 6 here. Like I'm thinking about, okay, no matter what, these are consecutive. I think that's the important thing to notice is no matter what, they're consecutive. So because if this is a 1, this can't be a 2 because we already have a 1, 2 pair here. Oh, so yeah. What I said originally is the correct thing. This is what I'm going to go down. If it's a 1, this can't be the consecutive one because the 1, 2 pair. So this ends up being consecutive. And if it's a 2, then this is consecutive and this is consecutive. So these are always consecutive. What can they be? They can't be 1, 2. They could be 2, 3, making that a 1. And I think that works just fine. They could be 3, 4. And that's actually what they'd have to be if this was a 2. 4, 5 is also possible. But 5, 6 is not. It breaks both of these cells. So either 2, 3, 3, 4, or 4, 5. That does not actually help me. I think this might be the same. Well, no, this could be... I could do 1, 2 here. So if this is these don't have to be consecutive because I could make these consecutive with this being 1, 2. Darn. Okay. So this didn't help me. What is going to help me? I don't think we can say there's no white dot here, for example, because just because we don't have an arrow doesn't mean there isn't an invisible dot there. Pretty sure. So I don't think we can do that. What else is there to do? Like if we knew all dots are given, but some are invisible. Yeah, there's no rule saying if an arrow isn't indicating indivisible, then it's not there. So I don't think we can use that. But I don't see how this is solvable otherwise. Oh, 6. Ah, that's what it is. It's 6 in this row. Right, this 6C's here, and these can't be 6 because it would have to be a 5, 6, because we know these are consecutive. So this is our 6. And so this is 1, 2, 5. Now that means down here we have a 6. I don't know how helpful that is. Okay, what can we do from this? What can we do from this? The two 6s look up. Putting a 6 in one of these two. We have 1, 2, 5. So these are actually 3, 4, 6. It's not a 6. Any arrows I've been ignoring? Oh, there's only 1 or 2 consecutives here. Right, maybe I should look more closely at that. So if we had 2 consecutives, it has to be here and here. So this would be exactly 2, 3, 4. Oh, but we need a 6 up here. Ah, okay. With the 6 up here, with this being 3, 4, 6, and the 6 forced up here, these are not consecutive. So there's no 5. 5's gone. Therefore, we only have one border that can be consecutive. And so it must be, because this can't be 0. So that's 1, that's 2. There we go. That's a 1. We get the 2 and the 1 here. This has to be a 3, so it's consecutive. And then we get the 6, giving us the 5 and 6 down here. This is 4. All right, we are getting Sudoku here. Phew. 3, 4, 5. That's not a 4. So we know one of these is a 4, and actually they have to be... Actually, because this is a 2, it has to go 2, 3, 4. I said that a million times, but now we know it's true. We get all these digits, 5 and 1. 3 in the corner. Emitting confetti there. I need a 2 and a 4 here. All right, down here I need 1 and 5. This could be 1, 2. Otherwise, these are consecutive. Actually, I can prove very easily that these two are not consecutive, because 2 consecutive digits always have 1 even and 1 odd. All our odds are gone. So if these aren't consecutive, then these must be. So that's a 2. That's 1 and 2. That's 5 and 1. That's 6 and 5. We get the 4 and the 2. This ends up a 6. And then we get the 3 and the 4, and we're done. 2 3s in the corner. Nice. So yes, I'm kind of wondering if there are any invisible white dots not pointed at. Yes, right here. Yeah, here's an invisible white dot not pointed at. So I was right to not use that. All right, here's another one. Cool. Well, that was fun. Thanks, GDC. For a little bit there, I was like, I don't know what to do, but yeah, it was just the 6. That was neat. I like that. Required us to think about how these had to be consecutive and thus couldn't be 6, and that placed the 6, and that was the really important deduction. All right, cool. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.